And we sat down for coffee, and he told me, my vision is that everybody could decide to launch their own satellite to space. So I thought, this would be a very interesting talk. So here is, please help me welcome Hojun Song.
안녕하세요. Hello, my name is Hojun Song. I'm not an English native speaker, but I try to speak English as much as possible. So bear with me if I don't speak good English. Hope interpreters can help me out my presentations. I am an artist living in Seoul, 32 years old. 31 years old. Um, Most of my time I spend like 13 years riding snowboarding. So even though I was majoring in engineering, I can't say my major is engineering because at that time I just snowboard. And then these are the things that I do as a hobby. As an artist, my work has something to with my hobby, but it's somewhat different from my work. Anyway, the reason I show this slide is just to let you know that what I'm presenting today is not kidding. I and my crew are capable of building a satellite, but yeah, small one. You might heard of I and I. Anyone likes to listening to reggae music? No one? When you listen to reggae music, you might hear I and I a lot. They use I and I to emphasize the togetherness instead of saying we, because I and I, it's like we're all connected thing. And I chose the word I in universe. I think it's too busy for us to think about universe all the time because we're in the middle of it, and we're busy raising our children. We're busy to think about getting promoted, and we're busy, driving on the highways. So we rarely have a chance to think about universe. And all the space programs were done by militaries or government, NASA's, the big institutions. So why not? Why not launch your own satellite? If there's a private satellite program, private space program, wouldn't it be great that you can think about your universe all the time and you create your own fantasies? So I named it collaborative fantasy. We've seen examples of collaborative intelligences these days. So I think it's time to have a collaborative fantasies. We have knowledge. It is actually you and I is the same because we use our internet as our knowledge basis. So, but then afterward, how about making some fantasies out of collaborations? And the reason I'm talking about fantasy is because a lot of people ask me, okay, what are you going to do about your satellites? I said, okay, I might not know, and it might be not as useful as what you think, but I think it will definitely create our fantasies. Think about robots. We have robots, but we don't have killer apps other than vacuum cleaners yet. But we're talking about robots a lot. And thinking about the rocket and the moon, UFO, and everything. It has nothing to do with our daily lives, but we say, we talk, we write, we make movies out of it a lot because we love fantasies. But I'm not just talking about fantasies today. I'm going to talk about brief background of why and I got into this idea. There was a CubeSat program developed by Stanford University and Cal Poly in California, San Luis, in U.S. And they thought it'd be great that if there's a small satellite program for university students. And right now, dozens of satellites up on the orbit, very small one. So they're trying to make some standard out of it. And I've been to conferences and I read all the theses from them, and I figured out it is possible. So, and it is there up on the sky right now, even though it's small. Why open source satellite and why and what? Why? Because I think it'd be great if we can have many people's idea. Think about NASA's and what other people doing. They have certain scientific missions in their space program. But as an individual, I don't want to use that as a scientific mission. I want to use it just for my own purpose. Put it into music, anything. So, but all those ideas got together, out of box thinking. You might be a farmer, you might be a driver, but you're dreaming about your own universe. It's like if someone just described the mechanism for the AIDS and the farmer in somewhere got an idea and make a cure for that. So I want to use that. And what the whole process and the whole database for the electronic components, so it's basically open source hardware, but we're going to open how to build, how to order, how to get a quote from the rocket companies and everything. And I actually did. So DIY, doing yourself satellites. Um, this, the one you're seeing right now is the technical spec for the current satellite that's been being built right now. So we're going to have RX and TX communication so you can communicate with your satellite on Earth. Solar charging is not just a one-time battery thing. And the sensors, some accelerometers, temperature sensors, basic sensors that's needed into controlling the satellite. Possibly attitude control. If you put your camera into it, then you have to control your satellite so that it can look towards Earth. Otherwise, your camera will burn up when your camera sees the sun. And plus, so this one box on your left is the module that we are going to build so that we can make it as a kit. And then after that, in addition to that, you have to add your own module, whatever that is. Because you're the one right now is going to launch your own satellite. And the orbit is in low Earth orbit, 600 to 2,000 kilometers is totally legal area right now. But you might think the stationary satellite that just sinks when Earth orbit, but that's too expensive and that's a regulated area. So we chose to launch our own satellite into the low Earth orbit, and it is legal. And life expectancy is 1 to 6 years, but it depends on the orbit. And before I tell you the process of how to build your own satellite, you have to remember these two words. One is a space grade component, and two is heritage. What space grade means is what you're using right now is they're all made up out of commercial grade electronic components. So it has a different temperature features. It cannot resist to the radiations, but the space grade one can resist to the radiations from the suns and from the universe, cosmic rays. So your computers cannot withstand up on this universe because of all the radiations things going on. So we have to have a space grade, but it's too expensive, and it's export license because if somebody is worrying about that their components might be misused by some terrorists or some other people, that they might build some missiles out of it. So my plan is we're going to use the electronic components that has a heritage. Means that has been to universe before using commercial electronic components. That's very cheap, but if somebody proves that this chip can withstand the space environment, then we're going to use that one. So for 3 years, I have been researching all the list for the commercial electronic components. And I have the list, but today, I'm not going to talk details about the electronic components because you can see it on the website. But I'm going to just skim through the general method of how to build your satellite. This is the actual size, 10 centimeter, 10 centimeter, 10 centimeter. This is the CubeSat that I talked about, the program developed by Cal Poly and Stanford. There's some other standard, but this is definitely the most popular standard. And the one you see right on the right corner is the CubeSat kits. They even selling kits out there. Okay. And the second one, the third one is the real assembly of a real satellite. Very small, but it's functional. You see the cameras and all the batteries, put it in together. So I just show you the side spec. And the solar cell. Solar cell is by far the hardest the components that we can get, because it has to have a very highly efficient solar cell. But this solar cell, I cannot tell you the manufacturer, but I got it, and it's not that expensive, but its efficiency is 27%, and we can use it. It's not export licensed. We can get it in here, Korea too, or your country. And also people talking about batteries. Hey, I want to use cell phone batteries in our CubeSat. Can I use it? Yeah, many people can think about it, but a lot of like space experts cannot, don't think that way, because conventionally very highly reliable batteries been only that type of batteries been used in space program, but these batteries been to space and it proved, and it's not that expensive. You can buy it. So, and how to make antennas, measuring tapes, fishing wire, nichrome wire. You wrap around your wrap the CubeSat or your satellite with the measuring tapes, and then tie it with the fishing wire. And if you apply high voltage around the nichrome wire, it will cut the fishing wire, and then antenna deployed. And maybe you know this one, Arduino. If you're an artist or if you're a hobbyist, then you might heard of this system. A lot of artists are using this electronic board these days, and they have a total developing environment. So I thought I just add two components so that it can resist to the space environment. Then I believe that even artists can launch their own satellites, because a lot of artists are using it right now. And this is the main controller for the satellite. And if maybe some of you heard of a Scratchboard from MIT, and if you can use the Scratchboard as a main board for the satellite system, then even kids can develop their own satellites. And how is it going to the universe? Piggyback riding. Can I go with you? I mean, this is actually not how it actually works, but by far this costs the most part of a whole launching plan. Making one is not that not expensive. This one costs 6K euro from one of the quotations I got, but it's not as it's less expensive than Mercedes or Porsche. So you want to buy a Porsche or a Mercedes, or you want to launch your satellite? I would launch a satellite. And this is how actually you put your satellite into the rocket. Inside, you have some kind of box. Inside is a spring, because you don't have any propulsion system. So when it goes up in the sky, it just springs out to the sky. So you don't know where your satellite is gonna go. And I believe that if we can actually, you should see the letter saying group buying. So the more you buy, the less you cost for the launching. And I am trying to team up with the 20 artists from all over the world so that I can cut down the launching cost. And probably one of the questions you might have, how we can use frequencies. Amateur radio band, totally legal, but you just have to request the frequency from the International Amateur Radio Union, and we use 144 megahertz, 435 megahertz to uplink and downlink. And since it's a FM radio band, you can even receive satellite data by hacking your FM radios. I'm sorry, I'm running out of time. And this is a portable ground station. I use iPod as a TNC terminal node controller, and there's a chip radio and a DIO-able Yagi antenna. Then you can receive data packets from the satellite. I even make T-shirts out of this. And since we use Spring, there's no GPS inside of our satellite. So you have to ask for collaborations from all the amateur radio operators on Earth. So your satellite goes off, it sends a signal to the Earth, and then somebody happen to pick up the signals, then they will let you know. So then if like 2 or 3 people pick up the signal, then you know where your satellite is. So it took about a week to know where your satellite is. But this is a cheap way, but it's good. So I'll use this way. And this one, you see that the little the bag on the left? That's the satellite. That's the satellite. This is the picture that I take at the CubeSat conference this April or May, yes. And they keep saying, "Hey, don't leave your satellite," all the time. It was so funny. I never heard that conversation before. And the funding goes like this. All the artists gathered together, Numi from Spain, Germany, Korea, James Powderly from Graffiti Research Lab. They helped me out designing all the T-shirts. And actually, my friends who's really good at distributing and exporting T-shirts, we calculated we think we can make out of money and the funds for the launching of satellites. So it's all about art and culture activities. And to make a $200 satellite, this is the real plan. So for the first by the end before the 2010 Q1, the building will be finished, and then the launching is scheduled at November and then September of next year. So look forward to it. And after we are successful, we're going to build a kit. And then this is the example usage. We measure the cosmic microwave, which is one of the proof of a Big Bang, and we'll transmit the lottery numbers on Earth. So whoever buy the T-shirts can apply to the lotto. And this is the controlling media satellites. So wish it when you want to. And you don't even have to have a receiver because it has a very bright LED, goes up on the sky, probably some country with war, then we will signal with the peace message in a Morse code. So I would say it's a space romance 2.0. There are some, for the last, there are some thoughts. So if we can prove this, then we are also worrying about some boomerang effects. What if we are really successful at this? One of my friends is DIYing the cold fusion reactors, and there's someone who's also making jet engines and rockets. What if we, as an amateur, proves that it is all working? And people are gonna regulate the internet too, just like what happens to the radio signals after the Titanic incidents. And here are some questions, the frequently asked questions that I had. Why do you launch your satellite? And I asked back, why do you listen to music? Why do you believe in religion? And other questions that I had. What is the return on investment in open source satellite initiative? Then I asked back, when you listen to music, do you think about your cells being rejuvenated or anything like that? It's about creating fantasies together with the help of technologies. 100 people's been out there out of total Earth populations. And I think and that includes dogs. Maybe you cannot see, but that space astronaut. But all the fantasies were created and fostered by those people. But I think it is time for you to make one and collaborate and make out of changes. And hopefully we can do it. I'm here to ask for help. Um, and I'll keep you updated as soon as some things got developed. So please keep an eye on this project. And thank you, and excuse me for the late presentation. Thank you.
Thank you, John. Stay there. Stay there for a while. Yes, you have to drink 5 glasses of soju during lunch. I'm very, very sorry for you. Question, you say people can help you. How can our community help you? What kind of support do you need?
For I had a funding rules. I don't get large donations because that makes a project not interesting. But I want to have a lot of cultural events because my issue is I like technologies, but I like the stories and narratives that comes out of the technology itself. So I want people to make some events together, make forums, and create
Raise money
stories.
for you, and also selling the T-shirts.
Yes.
Can I come to you today and ask you, I want to do my satellite? When can you do it, you think?
What was that again?
If I come to you
Yes.
today, somebody
Yeah.
come to you and say, I want to do my satellite.
Yes.
When do you think the satellite can be in space? How much time you need to make it happen?
Like from the roadmap, I just it's almost fixed, but September
September next year.
It's
Okay.
the first one.
Okay. We have the conference in October next
Okay.
year.
Okay.
So do you want a bit of pressure from us?
Yes.
And we could make an appointment that you come next year and you tell us how the launch went?
September.
You have 1 month vacation. It's good news for you. I think
Okay.
we'll try to have him back. Big round of applause for Hojun.
Thank you.